What if an AI could test the safety of the products you use every single day and do it faster and more reliably than a team of human experts? Well, today we're diving into a really groundbreaking study that shows how a new automated tool is completely changing the game for material safety. This is a big deal for science and, honestly, for all of us. So here's the plan. First, we're going to unpack this hidden safety challenge with nanomaterials. Then, we'll introduce the new AI hero that's stepping up to the plate. After that, it's a head-to-head battle, the old way versus the new. And spoiler alert, there's a clear winner. But even heroes have a weakness, right? We'll find out what that is. And finally, we'll look ahead at how this tech could really change our world. All right, first up, the nanomaterial safety dilemma. We're talking about microscopic particles that are basically everywhere, and they bring this huge challenge right along with them. Let's just start with a really basic question. We are surrounded by products that use these tiny engineered nanomaterials. They're in our sunscreen, our phones, even our medicines. But how do we actually know they're safe? How can we be sure they won't cause harm to us or to the environment? And this is where we run into a major problem, the safety bottleneck. You see, the traditional ways of testing stuff, on animals or cells in a lab, are just incredibly slow and super expensive. It creates this massive backlog. Now, computational models using machine learning can speed things up, but here's the catch. Building them has always required a highly specialized expert, a data scientist with some serious coding and stats knowledge. That high bar for entry really puts the brakes on innovation. But what if there was a better way? What if you could just get rid of that barrier? Well, a new tool is coming onto the scene that does exactly that, and it is seriously shaking things up. You know, to really get why this new tool is so cool, you gotta look at the old way of doing things. Building a standard machine learning model is this grueling manual process. You have to manually clean all the data, then you have to pick the perfect algorithm out of dozens of options, and then you have to painstakingly tweak all of its little settings. It takes a ton of time, very specific expertise, and a whole lot of computing power. And this is where our hero, automated machine learning, or AutoML, enters the picture. I mean, the name kind of says it all. It automates that whole painful workflow. It preps the data, it tries out tons of different algorithms, and it tunes them for you, all in the background. The huge promise here is that it lets the actual scientists, the people who are experts in their own fields, build incredibly powerful predictive models themselves. No PhD in data science required.
Okay, so you've got the old manual way and the new automated way. How do they really stack up against each other? Well, a team of researchers decided to put them in the ring for a direct head-to-head competition.
So here's the setup for the experiment. They grabbed 7 different public datasets all about nanomaterial toxicity. Then, they tried to build predictive models using 2 different approaches, the old-school manual machine learning way, and then again using 3 different user-friendly AutoML platforms, Google's Vertex AI, Microsoft's Azure, and Dataku. The goal was pretty simple. Which method could build better, more reliable models for predicting if a material was toxic? And the results? Well, they're in. And let me tell you, this wasn't a close fight, not at all. One approach was the clear, decisive winner. Now, if you just glance at these numbers, you might think, they look pretty similar. I mean, look at the accuracy. Both are pretty high. But here's the thing. When it comes to safety testing, not all mistakes are created equal. It is way, way worse to accidentally call a toxic material safe than it is to call a safe one toxic. And that's why we need a smarter metric. That's where this F1 score comes in. It gives us a much more realistic picture by balancing both kinds of errors.
And just look at that difference. The AutoML models hit an average F1 score of 0.81. The conventional, manual models, they were way behind at just 0.58. That's not a small improvement. That is a night and day difference in performance, and more importantly, in reliability.
So here's the bottom line. It's not just that AutoML performed better, it performed more reliably. The manual models were kind of all over the place. Some were okay, some were just awful. But the AutoML platforms, they consistently churned out high-performing models with way less variation. And when you're talking about safety, that kind of consistency is absolutely everything.
And this quote from the researchers themselves really spells out why this is so critical. A low score means your model is failing to catch toxic materials. It's letting dangerous stuff slip right through the cracks. And like they say, That could pose a serious health risk to consumers. AutoML's higher, more consistent scores mean it's just plain better at catching those hazardous materials before they can do any harm.
Okay, so AutoML is this incredible new engine for scientific discovery. But even the most powerful engine on Earth is useless without high-quality fuel. And in the world of AI, that fuel is data.
Now, the study found that all three of the AutoML platforms they tested, Vertex AI, Azure, and Dataku, they all performed really well. They just offered slightly different experiences. Vertex AI was the most plug-and-play, perfect for someone with limited experience. Azure and Dataku gave the user a bit more hands-on control. The main takeaway here is that there are great, accessible options out there no matter what your skill level is. But here is the single most important finding of this whole section. No matter which tool they were using, the researchers found a direct, undeniable link between the quality of the data they put in and the quality of the model that came out. It's that classic principle, garbage in, garbage out. Better data always led to better predictions.
And they even put a number on it. They used this metric to score the quality of the chemical data. And what they found was that models built on datasets with a high-quality score of 4.9 were way more accurate than those built on datasets with a low score of 2.8. This just proves that even with all the magic of automation, there's no substitute for the hard work of creating high-quality data. That's still the bedrock of good science.
So, what does all this mean for the future? Let's zoom out for a second and think about the big picture here. The really big takeaway is that user-friendly tools like AutoML are democratizing AI. They're taking this incredibly powerful technology out of the hands of a few specialists and putting it into the hands of the subject matter experts, the chemists, the biologists, the engineers. This empowers them to solve their own problems and to do it faster and more reliably than ever before. It could completely change the pace of safe, scientific innovation.
And that leaves us with one final, really exciting question. We've seen how this approach can revolutionize material safety. So what other doors could it unlock? What other massive, complex challenges could we tackle if we put the power of AI into the hands of experts in every single field? Just think about that for a second. The possibilities are really something else. Thanks for tuning in.